Good morning, everyone. Allow me to introduce myself. My name is Rayzha Citra. I'm a student at Civil Architecture, and my student ID number ends with 23.
And I, Tasya Fitria Azizah, and student number 148.
And we are ready to present our research analysis of the mechanical properties for paving block made from shell waste. Good morning, honorable examiners and audience. Today, Tasya and I are excited to present our research title, Analysis of the Mechanical Properties from Paving Block Made from Shell Waste.
We'll start with the why. Currently, the construction industry faces a sudden crisis since scarcity sand. Sand is the third most consumed resource globally, and its massive exploitation in Indonesia is causing serious riverbank erosion.
On the other hand, look at our coastlines areas like Gresik and North Jakarta are buried under tons of shell waste, creating sanitation issue and food odors. Our research aim to connect these two problems with one symbiotic.
Our primary objective is to test the technical viability of shell powder as a sand substitute. Can it meet the SNA Indonesian national standard for compression strength, and how does it contribute to green building principles?
To understand why this works, we look at the chemistry. Our XRF analysis shows that green muscle shells contain over 50% calcium oxide. Chemically, this is very similar to Portland cement, providing the necessary bonding of properties to hold the paving block together.
Physically, we process the cells into powder. The result, a finance models of 3.396, which classifies it as zone 1 coarse sand. This is the perfect texture for a filter metal in concrete mixture.
For our methodology, we use a consistent 1:3 ratio of cement to sand. We then created several variations, replacing the sand with the shell powder at concentration of 0%, 10%, 20%, 30%, and 40% to find the sweet spot.
Now, let's look at the data. As you can see on slide 8, the 10% substitution actually outperformed the baseline. It reached a compressive strength of 35.92 MPa. This is not just for set loss. It qualifies as SNE grade B, meaning it's strong enough for parking lots and residential roads.
However, there is a threshold. Beyond 20%, the strength drops. Why? Because the shell particles, especially from scallops, are flat and sharp. Without heavy mechanical pressing, the shapes trade air, creating micropores that weaken the structure.
But here is where it gets interesting. While high porosity reduces it creates a porous paving block. This is an innovation for small cities. These blocks allow rainwater to infiltrate the ground directly, preventing urban floods and runoff.
This is the essence of a circular economy. We aren't just making cheaper bricks, we are cleaning the coastlines and empowering local communities like Kalibaru to turn waste into a valuable commodity.
In conclusion, shell waste is a highly feasible alternative. To achieve maximum results, we recommend a 10% substitution and the use of mechanical press machine to ensure maximum density.
Sustainability is no longer an option, it's necessity. Thank you for your time. We are now open for any questions and discussion. Thank you.